Okay, so we're looking at this one question today. This is our mock practice 2. It's paper 2, the higher paper, again, non-calculator. So it says here, fraction arithmetic. Matthew is training for a race. He runs 3 days in 1 week, runs 1.5 miles on Monday, 1 2/3 and 2 1/5 on Saturday. The final answer is shown there. So let's just go through how that's worked out. So we know that it's 1.5. So here we go, 1.5 plus 1 2/3 plus 2 1/5. Okay, so really what you've got to do here, if you're adding it, you can just literally take the integers out and say, well, it's 1 plus 1 plus 2 is 4. And now I'm just going to literally add the fractions together. And a quick way to think about this is they've all got to have the same bottom number. What's the lowest common multiple? So lowest common multiple, if I just times them together, 2 times 3 is 6, 6 times 5 is 30. Let's assume 30. Okay, so to do that, I times that by 15. So therefore that's 15. I times that by 10, so that's 20. And I times that by 6. So that'll be 6 there. So that's 30, 5, 41. And then that's 41 over 30. How many 30s in 41? 1 with 11 remained. Plus the 4 makes that 5 and 11/30. Good. Then it says percentage change. Again, Susan buys an antique for £120, sells it for 206. Percentage change is always going to be difference divided by original times 100. Okay, so you're always going to do something like difference divided by original. The challenge is, what is the original? So in here, the difference is going to be 96, and then its original is 120. So what you can do, and because it's non-calculated, this is where people sometimes get a bit panicky. If I write it out like that, then I've got to think, right, what goes in? It's a non-calculator, what goes in? If it's a non-calculator at this level, it's going to be something obvious. Here, 12 seems to be obvious to me. How many 12s in 96? So in that process, you're thinking, okay, let's try and guess 8. 8 12s, 80, yep, good. So I know that 8 12s go into 96. And how many 12s in 120? It's 10. Some people even get that wrong. Now cancel out, boom, boom, that becomes 80%. Okay. Then the next one here is negative and fractional indices. It says, now, this is something we do need to work on because this is where people are making some fundamental mistakes. So look, remember, that minus just means the reciprocal, 1 over. There are two things happening here. There's this and there's this, they're separate things. So 5 to the power of 3 means 5 times 5 times 5. The minus simply means 1 over. And you can do it in either order. So I can write that as like that. That's exactly what this means. That, I've taken care of the minus now. That literally means 1 over. And then 5 times 5 times 5 is not 15, it's 125. A lot of people think it's 15, don't they? Because they get muddled. The next one was 25 to the power of 0. Now this is something you just need to remember. It's 1. Let's give you an example of why it works out as being 1. 2 to the power of 5 is 2, so it's 2, 4, 8, 16, 32. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. So I know that's 32. 2 to the 4, well, I'm going to say it's a 2 less. So it's a half of that, 16. And if I keep this pattern going, I can see I'm always dividing by 2. Just bear with, you'll see why this works so well to explain it. So clearly, 2 to the 1 is 2. Now let's just take one more step. I've gone down 5, 4, 3, 2, 1. Let's go to 2 to the 0. Follow the same rule, same pattern. 2 divided by 2 is 1. Whatever you use, whatever system you want to do, anything to the 0 is 1. And then we get this one here. This is 1,000 to the third. Now that means the cubic root. Sometimes written like that. You'll seen it in maybe something like the 100 to the half, meaning the square root of 100. So that's what it means. Sometimes they put a 2 in there. If they don't, it means the square root. So this essentially says I've got a cube of 1,000 centimeters cubes. Okay, what's the dimension? What if it's a cube? It's got to have the same x, x, x. What do I times by itself by itself? The answer in this case is 10. Then recurring decimals. So you got here 0.5121212. So let's just say, right, okay, that's my setup. I'm going to call that 1n. I want to take the 5 out. I want to take the one whole cycle out. So I'm going to take all of that out. 10, 100, 1,000. So if I times it by 1,000, I get 512.121212. Dot, 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 dot. So now that's cool. I want to get rid of all of this. How do I do that? Well, look, if I times this by 10, I get 5.1212 dot, dot, dot. That's so cool. Now take away those two. So I'm left with 990n equals 507. And that means n is 507 over 990. Now I need to check, does 3 go into these? Yes, it does. Because if I count 5 plus 0 plus 7 is 12. So 3, there's a little trick there. 3 goes into 12. So 3 will go into this. I'm pretty convinced. So once, twice, 3 6s are 18. And then 3 9s. So there you go, 169. How many 3s in 9? 3, 3, 0. Okay, 1 plus 6, 7 plus that is 16. 3 doesn't go into that. So I think I'm pretty happy with that being it simplified in its simplest form. Always check with a calculator at home just to make sure you've got it right. Okay, I'll do the other ones in a minute.